We can all agree, as a customer, there's nothing more frustrating than buying something pushed in front of you as a recommendation that never truly meets your expectations. In fact, a single bad experience can break trust. 1 in 3 customers will abandon a brand they love after just one disappointment. So the real question for retailers today isn't just what to promote, but how to stand out in a world flooded with products and advertising, creating relevant experiences that connect the right customers with the right brand in a compelling and meaningful way. This modern approach is increasingly known as a brand amplification. And in this video, we are going to explore how data and technology play a key role in making this possible, enabling results that truly reflect what the customer is looking for, while still supporting the brand strategy the business needs to drive. To understand how this works in practice, we will look at how product discovery and brand objectives can operate together through a real store scenario, using an application powered by MongoDB. I will leave the repository and documentation linking in the description in case you want to explore more or even run the entire demo in your own environment. We will go deep into some of MongoDB's capability, especially the aggregation framework. As well, we will look at the why MongoDB as a modern data platform becomes essential in a world where data complexity keeps growing and AI-driven experiences demand more from the retail ecosystem. Now, let's reframe the situation for a second. Imagine you're a store associate. You are helping customers one after another, and everything depends on the app in your hand. You are navigating a huge product catalog. Promotions change daily, inventory shifts by the hour, and you still need to meet your sales targets by the end of the day. So let's break down how MongoDB actually enables an intelligent sales flow. First, let's look at the functional, and then we will explore the engine behind the scenes. In our store app, we will see 2 roles. 1, the store associate, using search advanced features to solve the customer's need and explore the catalog, which is always keep in sync with real-time multi-store inventory. 2, the store manager uses the back-office portal to define brand-boosting priorities in real time for that specific store, adjusting based on partnership, seasonality, or new marketing campaigns that need to be managed in a constant change. So I'm the store associate helping a customer who says, I'm looking for skincare for my dry skin. For this type of need, I would choose vector search mode, which captures semantic meaning beyond the exact word typed. If you want to dig deeper into the full range of search strategies MongoDB offers, full text, vector, and hybrid, check the links in the description. For now, let's focus on how we handle this sale. When I run the search button, I get a wide selection of relevant products because many items truly match that need. But what about the business priorities of the store? Maybe the brand I need to highlight now, according to the store's brand amplification priorities, is buried on the second page. This is where brand amplification kicks in. I repeat the search with brand boosting on, and MongoDB ranks the results in real time, respecting intent but surfacing the brands the stores need to highlight. Same options, smarter order, a recommendation that honors the customer's need and supports the business at the same time is what turns a simple search into a real experience. So now let's go behind the scenes and understand how MongoDB powers this experience. There are 4 core components in this architecture, but we begin where everything starts, with the data. In this demo, all the essential data lives inside MongoDB, acting as our operational data layer. That means we centralize the key information needed to deliver a consistent experience across every channel, stores, e-commerce, mobile apps. That information will normally be trapped in silos like inventory platforms, marketing tools, pricing engines, and so on. This is a huge topic on its own, and we have covered it in our Retail for Innovation series. But here's a key point. The flexibility of the document model is essential to know how we scale this demo solution. For example, each product document stores an inventory summary for 50 stores. This lets the search pipeline instantly know which products are available in the associate's current location without extra lookups. And just to be clear, when I say lookups, I mean cross-collection joins. Avoiding those joins at scale makes a massive difference in performance. At the same time, the raw inventory events coming from different sources go into a dedicated collection optimized for write-heavy workloads. Whenever the stock level flag changes for a specific product, Atlas triggers automatically update the product's inventory summary, so the catalog stays in sync in real time, maintaining data consistency. So the key point here is understanding that MongoDB's data modeling principles are designed around workloads, so reads and write remain efficient at any scale. But for now, let's recap. MongoDB is acting as our data platform, storing products, including the embeddings LLMs used to capture meaning, along with inventory, stores, and the brand amplification rules. So let's return to our store and look at the main application we are using to assist customers. It handles both interfaces. The Store Associate UI used to run the search, and the back office configuration where managers define brand amplification rules. When the associate types the customer query, the app builds a single request, including the query itself, the selected search type, and the brand amplification rules retrieved from MongoDB, and sends it to the single component, the Advanced Search microservice. The microservice then sends the query skincare for dry skin to Voyage AI, our embedding provider. Voyage AI transforms that text into a vector embedding. With the embedding, the store context, and the brand amplification rules, the microservice builds a dynamic aggregation pipeline inside MongoDB. And this is where the aggregation framework becomes the real engine of these solutions. MongoDB's aggregation framework lets us process data through a sequence of stages: filtering, scoring, sorting, merging, and shaping the final response, all inside the database in a single round trip. For semantic intent, the pipeline uses $vector search to find the products whose embeddings are closest to the customer's query. For text relevance, $search applies compound logic, combining must, should, conditions, boosts, filters, and so on. On top of that, MongoDB gives us scoring mechanisms like boosting, function-based scoring, and the native vector text scores, all of which let us reshape ranking dynamically inside the same pipeline. This means we can elevate certain brands or any attribute without breaking the customer intent. We keep the intent signal intact and adjust the score based on business strategy. And of course, all of this sits on top of MongoDB's operational backbone. Replica set ensures high availability, sharding lets you scale horizontally, and you can run dedicated search nodes to keep queries fast without impacting the main workload. ChainStream and Atlas triggers keep data flowing in real time in event-driven environments, and everything is secure end-to-end with access control, network isolation, and encryption both in transit and at rest. So here's some food for thought. In this demo, boosting comes from store-level brand priorities, but online, the same machine could boost results based on each user preferences, meaning the same query could generate a different fully optimized ranking for every single customer. That level of personalization is completely up to your use case, and MongoDB gives you the ability to deliver it. And that's the kind of intelligence that turns product discovery into real retail experiences.